Welcome back. So in our last explainer, we took a look at how MCP helps AI connect to external tools, things like databases and APIs. But that actually brings up a brand new question. When the AI is searching inside those massive systems, how does it actually find the right information hidden among millions of documents?
I mean, really think about it for a second. An AI assistant might have access to thousands of documents, millions of files, just endless sprawling databases. When you ask it a question, how on earth does it pinpoint the exact useful piece of information in literally milliseconds? Well, to solve this little mystery, we actually need to take a step back and understand the old way we used to search for things.
For a really long time, we relied entirely on something called keyword search. It sounds familiar, right? But here's the absolute major limitation with that approach. Keyword search only matches exact words, not meaning. Let me repeat that. It only matches exact words, not meaning. So, if you search for the word chicken, the system is literally only looking for documents containing those exact letters, CHICKEN. It completely misses what you actually want if you use even slightly different phrasing.
Let me give you a super simple example. Imagine 3 different users, and they are all having trouble getting into their accounts. One types login error. Another types cannot sign in. And the third types authentication failed. Now, you and I instantly know these mean the exact same thing, right? We get it. But a traditional keyword search? Nope. It treats them as completely different problems. If your help center only has an article titled authentication failed, while the person searching for login error is going to find absolutely nothing, 0 results.
To really visualize this, let's use a restaurant analogy. Imagine you are at a massive restaurant with thousands of recipes on the menu. A customer comes in and asks for something light, healthy, and not too spicy. A keyword search is basically like having a chef who only looks at the exact names of the dishes on the menu. If a dish isn't explicitly named light, healthy, not spicy soup, they just can't find it. But a vector search, that is like a master chef who truly understands the taste, the ingredients, and the similarity of the foods. This master chef totally understands that low-calorie and diet-friendly belong in the exact same category, even if the words used are totally different.
Okay, so let's dive into the solution for this whole mess. We call it a vector database. Simply put, a vector database is a system that searches using meaning instead of words. I really want to let that sink in for a second. Searching using meaning, not words. Instead of just saving a giant list of letters, it saves a map of ideas. It groups visually similar problems or concepts closer together, kind of like neighborhoods or locations on a city map. But that brings up a really fascinating question. What does meaning actually mean for a machine? How on earth can a computer, which, let's remember, only runs on ones and zeros, how can it understand an abstract concept like a login issue or a healthy meal?
Let's walk through exactly how this works step by step. First, we convert the text into a meaning representation. Second, we take that representation and store it in our database. Third, the user comes along and asks a question, something like, "My login is not working." Fourth, we convert that user's query into that exact same format we used earlier. Fifth, the database looks at our conceptual map and finds the closest matching meaning. And finally, it returns the relevant results right back to the user.
Bringing this all back to our restaurant analogy for a second, a vector database is basically a super intelligent pantry organizer. It organizes everything based on taste similarity, ingredient similarity, and dish similarity. So even if the requested dish has a completely different name from what is written in the official recipe book, the system still finds the closest meaning match. It just knows that grilled poultry is essentially another way of saying chicken.
So, here's the really crucial point to take away from all this. AI does not understand language like humans do. It just doesn't. It isn't actually reading these words and comprehending them the way you or I would read a novel. Instead, it is mathematically measuring how close different ideas are to each other. It doesn't read, but it measures the similarity of meaning incredibly effectively.
And honestly, this brilliantly illustrates why this technology is suddenly everywhere. Real-world data is messy, right? People just don't always use the exact same words. That's why vector databases are powering the tools you probably use every single day. We are talking about ChatGPT's file search, Notion AI, GitHub's code search, massive customer support systems, and even the recommendation engines on your favorite shopping apps. Basically, any system that seems to magically understand what you mean rather than just what you typed is absolutely using a vector database behind the scenes.
Now, if you happen to be familiar with RAG, that's Retrieval Augmented Generation, all of this probably makes perfect sense. In fact, vector databases are exactly what make RAG possible in the first place. The vector database acts as the retrieval engine. It goes out and finds the relevant information based on its meaning. Then, the large language model steps in as the answer generator, taking that retrieved information and speaking it naturally right back to you.
So we now know that a vector database acts kind of like a map of meaning, measuring similarity rather than just looking for exact words. But that leaves us with a pretty fascinating question. If AI stores meaning as numbers, how does it actually create those meaning representations in the first place? How can plain old numbers represent complex ideas like login issues or specific food recommendations? Well, that is exactly what we are going to uncover in our next explainer all about embeddings.